Prepare to have your mind blown and your imagination unleashed as we embark on a mind-bending journey through the captivating realm of scientifically possible extraterrestrial life forms. Get ready to encounter alien wonders that will forever alter the way you see the universe. Are you ready to meet our cosmic neighbors? It's a question that has grabbed the attention of humanity since long before history has been recorded. What life exists outside of this little ball that we call Earth? Whether we're talking about the gods of Olympus or the Klingons of Star Trek, it is a theme that has appeared consistently throughout all of human history. Science predicts many examples of counterintuitive forms of life. While impossible on Earth, they could very well exist elsewhere in the universe. So, without further ado, here are the top 10 scientifically possible extraterrestrial life forms. 1. Silicon-based life. Silicon is a molecule whose structure and chemical properties are remarkably similar to the properties of carbon, the element on which most life on Earth is based. An important part of life, as we know, carbon can form complex chains of atoms and molecules sufficiently large to contain biological programming, such as DNA. Silicon, also commonly used in computer chips, is the closest that humanity has ever come to designing its intelligent system. It would have the potential to organically form its version of DNA under the right circumstances. 2. Arsenic-based life. Although it seems counterintuitive that one of the most iconic poisons on Earth has a basis in forming life, science suggests that arsenic can be incorporated into complex biomolecules. The argument for arsenic in life forms stems from its chemical similarity to phosphorus, a staple part of DNA in Earth's life. Some studies suggest that arsenic may have once been a part of the DNA in early life on Earth, taking place in DNA that phosphorus does now. 3. Ammonia-based life. Water is an essential part of all Earth's life. Our bodies use liquid as a solvent, which is necessary for almost all chemical reactions that create energy and sustain functions. This is seen in humans and down to the smallest microbes. But what if there was an alternative to water? Recent science suggests that there is. For life to exist in a substance other than water, it would be necessary for it to either have a large temperature range at which it is liquid or exist on a planet with little, if any, temperature change over its year. 4. Methane-based life. There are some environments in which methane would be far more prevalent than water. Saturn's moon, Titan, is a prominent example. According to a computer model, life which relies on methane would be able to exist in extremely cold areas as well as regions entirely without oxygen. The model revealed that a cell wall could be constructed that would work in liquid methane at -180 degrees Celsius, -292 degrees Fahrenheit. Along with the fact that cell membranes could be created with nitrogen, carbon, and hydrogen molecules, which are known to exist in Titan's oceans, this function means that simple organisms could exist in the frozen depths of methane oceans. 5. Carbon-based life. Carbon-based life forms are the only type which we, being carbon-based ourselves, know anything about. Thus, we're sure that hundreds of planets exist within the potentially habitable zones of their stars. These planets would be able to support life as we know it with oxygen, liquid water, and even the chemicals and reactions necessary to jumpstart life. Additionally, carbon-based life is the only type that we are sure exists, as evidenced by our planet. This isn't to say that carbon-based life on other planets would look at all like Earth's. Through evolution, extraterrestrial carbon-based life can take on a dramatically different form by adapting to fit its environment. 6. Hybrid life. If creatures could hypothetically evolve using an entirely different basis for life than that on Earth, why couldn't they combine multiple methods? For example, life could be based primarily on silicon, contain elements of carbon or arsenic, and use ammonia as a solvent. As previously mentioned, some life forms on Earth incorporate silicon structures into their cells. So why not take it a step further? If an organism evolved on a planet with a relative abundance of multiple elements that could be used in the processes of life, why not take those two and make them into a composite whole? Silicon and carbon can bond with each other as well as silicon and oxygen, carbon and oxygen, and silicon and fluoride. 7. Plasma-based life. This one truly falls into the realm of science fiction. By modeling conditions that are possible in space, a 2007 study found that plasma and dust can function in a way that may qualify as life. They may even form microscopic double helix strands of solid particles through the polarization of plasma and dust. Sound familiar? Even more fascinating, the study found that these strands can change, such as those associated with organic molecules, specifically DNA. They can divide, copy, and even evolve as less stable strands break apart and more stable ones endure. 8. Celestial life. Although science does not currently suggest that stars or galaxies themselves could form life, it does indicate that life with organic compounds can form outside of a home planet with the help of nearby stars and star structures. Using the Atacama Large Millimeter/Submillimeter Array, organic compounds have been detected in the Large Magellanic Cloud, a satellite galaxy of our own Milky Way. Complex organic molecules such as methanol, dimethyl ether, and methylformate, all of which are essential in organic life, were detected in 2 nebulae in the Large Magellanic Cloud. 9. Panspermia. A popular theory is that life propagates through the universe through planetary ejection caused by large impacts on previously populated planets. This theory states that life can be distributed by dust, debris, asteroids, and comets carrying microorganisms from other planets. For panspermia to be plausible, the organisms must be able to survive intense forces and extremely hot and cold temperatures for extended durations. This is due to the inherent forces involved in an asteroid impact, the heat from friction with a planet's atmosphere, and the extended time when the organism is in transit through space, potentially thousands or millions of years. 10. Nothing at all. Unfortunately, we may be the only planet in the universe that has life. Due to the vastness of space and the limit that light speed imposes on intergalactic travel, it may be impossible for us to ever discover other life or even determine if it exists at all. In the observable universe, we have not found any concrete evidence that life does or has ever existed on other planets. As we reach the awe-inspiring conclusion of our exploration into the realm of scientifically possible extraterrestrial life forms, we are left with a sense of wonder and anticipation for the boundless diversity that may exist beyond our own planet. From the potential for microbial life thriving in the depths of icy moons to the tantalizing possibility of technologically advanced civilizations elsewhere in the universe, these 10 extraordinary possibilities awaken our imaginations and challenge our perceptions of what life truly means.